Alright everyone, so let's proceed our development. So where we were yesterday. Hmm, hmm, hmm. Okay, so our arena.ca seems working. We have done the modification for all the files, and the files include, first of all, tensor abstract. The other one is multi-head attention, layer norm, and V4 neural network. All the layers of our transformer model. We're done with modifying our arena architecture. In case if you're not sure what is arena architecture, you can see my previous videos. And let's check the main file of our framework. So that's actually the main file. All the files are linked here. So let's start modifying this as well. This is going to be new. It's going to take size new. Fine. Create new and pass the shape alongside arena. So we need to create an arena over here. So our arena will be something um, arena initialize, and it's gonna take size t size equals 1024 24. Mm, arena initialized, you mean arena init is, like I said, I just can't get that right on the first go. I don't know why. Just not allowing for some reason. Long unsigned integers. So what is inner arena.h? So it's size t, base and offset. Arena and oh, I need to allocate first arena. My bad. So first of all, arena. So at the very first time, we'll be using malloc once. So the entire purpose of creating this arena is to not use this malloc again and again, right? So at first we need to use it initially, something like that, and then it's gonna take it's gonna be size of a, yeah, this should work, and a and size. No, it looks fine. So dimensions, create seed, let's just do it here, and this is the arena block, and this is the shape. This is going to be our shape. Yeah, fine. How is the tensor gonna look like? This is gonna take arena. Undim. Create new text. Yeah, so fine. And dimension shape. This is going to be fine. And this gives me size, and this is going to be here a shape of target. Yeah. Also define arena, give arena here. Okay, let's have a quick recap. So size to size is this. So it's going to create a huge block of arena, right? And then we have number of dimensions and then shape. That's right. Uh, and let's create a shape pointer here to avoid conflicts. Uh, and we can use shape every single time. No, I think Tensor Create already does that for us. This already does that for us. So it's we'll extract these indices and we'll assign 0th index sequence then in the first index as embedding dimensions. And this is going to be my A. Let's pass arena here. Fine. Till here everything looks good. Okay, so target tensor and everything. So chunks. MHA create. This is going to be new. Excuse me. Layer norm. So what we did with layer norm. Let's just search for keyword new. Layer norm new. Fine. Just like the previous ones. New one's gonna also take arena. Oh man. Yeah. Right. Correct. FFN create. Vim FFNC new. So I modified the existing function for FFN. I don't know why. So we'll refactor this code later. For let's get this work for now. Arena. This is going to be new. And what arena? So log the files. These are actually log the files, which are gonna log our loss for each epoch or each batch, I guess, not epoch. So inside epochs we have batches, and it's gonna log the loss for each batch, and then everything starts here. So we've created the initial pointer to the first byte of target data and our actual data, and then we have this shape of local, and then we are creating tensor. Do this here. Boom, looks good, looks fine. I don't know whether this work or not. I don't know. To do, check this code down. May have bug. Okay. Attention score. Yeah. Vortex. Clip gradients. This is going to clip the gradients for us. Tensor check. Layer norm forward. Yeah. Now, let's see what happens here. Layer norm. Okay, so this will be something like this. We are passing arena, and rows and columns. So it's going to take shape from here. That's fine. Till here, everything looks fine. So this, what will happen is arena alloc, and now arena alloc takes arena, and let's quickly check what it takes. uh, mm, yeah, arena alloc, arena, and size. So size is going to be okay, rows times size of float. Rows times size of float. Rows are going to be this way, and float means for every single element, right? Let's run this for now and see if it works, and we'll make changes later in case it doesn't. uh, a tensor free new tensor create. This is going to be our output vector and takes arena, x row, y row, x data, y data. Looks good, it looks good. Gamma, yeah, fine. New, forward. So just pass a here. uh, yeah, this takes arena. It's already 10, so uh, this is just gonna take arena. L2 takes arena, and yeah, loss. So what loss does, let's just analyze loss. Loss is here, and what loss does basically is I just take two tensors and tensor create weights new. This is going to be new, and it's gonna take an arena as well. uh, Arena A, mm, arena, and yes, and yes, everything is fine. So we need to go to the tensor dot header file and change its definition here. So MSC loss is something like this, so it's gonna take arena A as well. Okay, yeah, fine. Just pass an arena here. Loss value, this is nothing. Okay, let's just quickly check this as well. Tensor dot c, and what is loss value? Yeah, it just calculates the value and returns a floating point number. It's nothing. Tensor create arena and do arena, print all good, layer norm backward. This is one of the most challenging functions in this entire framework, layer norm backward. It's got several things to do, because when you take the gradient of layer norm, what happens is basically you have lots of different mathematical operations implemented inside layer norm. That is like taking mean, variance, um, element-wise arithmetic, and matrix multiplication. So these are four different types. So when you backpropagate and take the chain rule, you have to do different paradigms, approach different paradigms to calculate the gradients for everything, which are going to flow back. So this makes it very, uh, not very difficult, but a little challenging. And we're gonna check this later, how this works. I'll make a separate video on that. So layer norm, backward. So yeah, we need to make the changes here. So first of all, it's gonna take arena, and now uh, mm, are we creating any tensors here? No, we aren't. We aren't creating any tensors here. Yeah. We just need to pass arena. Is that it? Okay. So are we creating any shapes? Calculate gradients. Accumulate gradients. So dy. This is dx. I don't think it has to do anything with the arena. So let's just not pass it for now because we're not allocating any memory here. Let's just let it go this way. This is layer norm backward. Okay. FFN now C in backward. What is backpass? Yeah, we've done this. FFN is love. You know what? When we have fully connected neural network, what happens is basically, let's just sketch this down here. Let's just create something here. So sketch. Okay, so when you have something like this, for example, when you have something like this, this is our first matrix, and this is going to be multiplied by second matrix. So if we are to find the derivative, what will happen is dy would be derivative of matrix A times transpose of B. Transpose of B. So it's just very simple. So take the derivative of matrix A, multiply it by transpose of B. So you'll find the derivative of Y, which is actually the matrix multiplication product of these two matrices. So it's very easy. Feed-forward neural network is the easiest thing in this entire framework. So forward and backward both the passes. But now where we were, we're here. So we just did backward, and backward is going to be layer norm backward, and yeah, MHA backward, FFN backward, just pass arena. Yeah, we have modified it as well. FFN backward will take this, and this takes nothing. This takes nothing. I think this is new, maybe, or not. We'll have to confirm, but arena certainly there. Backward, okay. I think no new. Clip the gradients, and then gradient updates, and then do this, and voila, are we done? Let's see. And I expect to get a ton of errors, and let's check those out. redefinition of arena. Are you serious? Okay, why don't we just open another terminal, and that way we don't have to open the files and close them again and again. So let's just run it over here, and boom, there it is. All right, so uh, mm, all right, so it says arena, uh, line number 8. Oh. Okay, I declared it twice. Huh. Even though I'm not compiling this. This won't resolve this. This won't resolve. Redefinition. So redefinition. Really? Yeah. That's correct. Yeah. Man, it just returned null pointer. Nothing. This one is not right. Redefinition. Arena init. Arena init. Okay, so arena init and arena allocate. So it takes A, and what is arena init? Init. Oh, shit. Okay. N dimension. This is right. So main 33 has issue. Yeah, definitely a valid one. Okay. Tensor H. Tensor H. Tensor dot H has issues. What is it? structure arena pointer segment is integer. Tensor new. Tensor new. So creating actual data tensor. Tensor new. Shape. Why is it not working? What is wrong? Yeah, there is gone. So clip gradient, implicit description of clip gradients. Main clip gradient. Where it is, by the way. Tensor.h clip. It's not here. Vim ffn.c. Really? Oh, I committed it out here, and I've not defined it in tensor file as well. So, or have I? Let's just check. Tensors.c clip gradient is not here. Let's just take it here. It only takes one tensor, turn nothing. Now what? Warning, passing layer norm forward from incompatible pointer. Layer norm incompatible pointer, aka arena. What is this? Passing argument 1. Layer norm. Let's see where. And then dot C. So forward takes arena. Returns tensor. Yeah, something is wrong here. Okay, what else is the problem? Passing argument 2. Passing argument 2 of layer norm forward from incompatible pointer. Layer norm forward, layer norm, attention score. L1. This looks good. Layer norm create. There must be something wrong with layer norm create. Yeah. So create new has the right definition. Layer norm dot h. Where is new? Yeah, this looks fine. Forward and backward. Okay, let's see. Let's run it again. Sometimes one error is related to the previous one, so when you resolve the previous one, it just magically disappear. Oh, okay. Undefined reference to any. Yeah. have arena there. Man, what just happened? Undefined reference. In function main. So if I check run, what's inside the run? So I'm linking ffn arena. Where is arena? Yeah, yeah. Arena initialized. That's the issue. Where does arena fit in? Yeah. So let me just open this file and show you. So these are actually the files that run kind of like sequentially. So for example, we have tensor abstract. We get all our tensor related functions, whether it's mapmul, whether it's gradients, whether it's scalar multiplication, whether it's tensor addition, whatever this is, we get it from here. Then we have a tension layer, and inside the tension we have forward attention mechanism and backward. So we update the parameters as well, and we take the forward and backward results from this file right here. So we add its header file and prototypes, and that's how we are able to use this. Then we have uh, layer norm. So we are running these layers sequentially one after the other one. Now the point is, arena, what it does basically, it's not a layer actually, it's a memory manager. So this should not be sequentially fit in our code base. So where do we fit this in? I mean, where should arena be? I don't know. Okay, so let's define arena before even tensor, on the very bottom layer, because it manages right there. And let's see. So we are able to launch our arena, but there's some problems. Invalid pointer, free. At some point, we're trying to free this arena. Listen, so we have actually written this function tensor. Let's go to the file called tensor.h, and this is tensor free. See, tensor free. What it does basically, so it takes the tensor, and its definition is right here. Tensor free. So tensor free, what it does basically is it just frees the data of the entire tensor, whether it's data, whether it's stride, shape, and lastly the tensor t. So free must be, dealing with malloc, but we are not using any malloc here. We've defined our own arena lock, which is actually a counterpart of malloc, and kind of returns the same thing. It returns a null pointer to the last byte of our arena, right? And now we need to figure out where actually are we using this tensor free, and how can actually we create our arena alloc free or arena free method, which does this exact thing, dealing with our defined pool, not actually the malloc. So yeah, I think this is enough for now, and I'll be catching you later in the next video for part 2. Thank you so much.